welcome. And thank you so very much for joining me on another episode of Talking Cloud. Now, this is where we talk about cloud, anything cloud, all things cloud. It's no holds barred. We'll talk about anything. I mean, come on, let's face it. Just about every aspect of computing today involves the cloud. And man, I'm so jazzed because you guys know I'm just the Gilligan in this equation. But being an old guy with no hair, I've met lots and lots of folks. And man, I'm so lucky today because, it's funny. I was looking through past guests, and this seems to be a common theme. Checkpoint's been around for so long. It seems like just about anybody or everybody has worked for or with Checkpoint at some point in their career. And certainly that's the case with Ori. So let me just do as I normally do and kind of run through Ori's experience before I reveal who we've got. But seriously, this is going to be awesome because, this whole industry is leaning more technical. It's leaning more towards the developers. That's not to say it's not more accessible to the masses, but that's because of the brilliance of the technical folks, in my opinion. And I've got a really great one today. So, 20 years ago, he was doing automation engineering, software engineer at Web Silicon for a while after that. Here he was a senior software engineer for Checkpoint for nearly 3 years, then went on to Compass Networks, where he was nearly 6 years, to a company we've all heard of, AWS. He was manager software development. You see a theme here. Development. Drive Nets. He was there for a little over a year as director of software development, and then landed where he is today. Ori's been at Akeyless Security now for, it looks to me like 5 years. He can give
almost
me
5 years. Yeah.
Almost 5 years. And I'm super excited today because I've got with me just a super bright technical guy that's an expert in the industry, Ori Mankali, Senior Vice President, Engineering at Akeyless Security. Man, I'm so happy to have you here on the program. Thanks for joining me, Ori.
I'm very excited to join you, Grant, and thank you for hosting me. I'm really thrilled to have this conversation with you today. And let's get this started.
Yeah, well, so I'm taken by your tagline right away. Akeyless, secrets management without the management. So it's just secrets. Why don't you, I kind of just skimmed over like a skipping rock your 20 plus year career. Talk a little bit about your history, your career, how you got to where you are and what you guys are doing at Akeyless.
Sure, absolutely. First of all, I think that it's part of my, I would say, DNA to talk and work about technology. And to me, it's like my passion, something that I have been doing for a very long time. Initially, it was like a hobby to me. I did a lot of learning and research even before the internet and all the technology that we see today around us. And over time, it became a profession. I basically made my hobby something I make a living from, and I'm happy for that choice.
Yeah.
Initially, I was working for different companies and doing some software development work from the very beginning. I was practicing different kinds of technologies in different realms, user space applications, and then I switched to some kernel side development, things that are more related to networking and kind of a low level implementation of things. Today, I'm mostly focused around the security realm, security applications, and all that comes with it. I'm actually managing a software development group. We have built a security platform that has several use cases and products around it, starting from secrets management. That was the very first product that we launched on our platform, but today it's expanded to different use cases like certificate lifecycle management and password manager, secure remote access, which is the ability to allow dev teams to connect to remote resources in production, for example, and many, many other use cases. So it's
Boy,
a lot
that's
of,
boy, Ori. I don't mean to interrupt, but I'm just thinking that secure remote access really, really became a significant issue with COVID. Right. I
Yeah,
mean,
absolutely.
before I mean, from when you worked at Checkpoint, Gil adamantly against any remote access for development, right? I mean, he was a maniac. You had to go into the office if you were doing any development. Nothing would ever leave. And then we had to accommodate COVID, and that changed the world drastically, right? I mean, that was a very big thing.
I can't agree more with you. I think that what happened is that even companies that are more traditional in the way of thinking, in the way of operating their teams, etc., had to adjust themselves to the situation, which is by all means unique and something that our generation have not remembered
Yep.
in decades. And then you had to find technical solutions, because if initially, let's say that you did have some kind of a VPN to your office network or whatever, I'm sure that many organizations didn't cope with the scale. What happens with lots of employees try to connect at the same time, and what happens if the bandwidth is not sufficient to do their work? And all of a
Yep.
sudden, they had to find quick solutions in order to not to lose money.
It was
So I
ready,
think
fire, aim, right? Ready, fire,
exactly.
aim. And then the next 12 to 24 months, course correcting, going back and fixing what they did in haste.
Yeah, absolutely. And I think there are also many security concerns when it comes to exposing services, exposing infrastructure to the outside world. To begin with, you had to at least have a single port, TCP, UDP, depending on
Right.
the software, exposed to the world. You have some kind of identities, different kinds of identities that are allowed or authorized to log into this environment. Otherwise, what's the point?
Yep.
And by introducing that, you basically introduce new types of risks to the organization that had to be mitigated and taken into account.
Yep.
So software applications that are SaaS, meaning that you don't have to establish the matching infrastructure in your environment. You don't have to maintain them. You don't have to do the heavy lifting of managing them, are very attractive to organizations if you want to do things the fast way.
Yep.
I think that this has become very popular. And also there is another concept that was adopted around the same time. I haven't thought about if those are connected or not. It's called zero trust application access or zero trust network access, depending on what your marketing slogan
Buzzwords.
is. But it's mostly around defining who is allowed to access resources inside your network. Traditionally or historically, if you were on the same network, the corporate network, you could have access to multiple devices and resources. And with applying the zero trust concepts, you basically have to prove or to assure to the resource that you're authorized and authenticated, and with that get access. And this is increasing the security level of services inside your network. So it's not just enough to have network access, you also have to be authorized, and that was becoming very popular around the time.
It's funny,
I think that
for me, I mean, as I introduced you and admitted, I'm the Gilligan. And so for me, I often will oversimplify in an analogy, but here's how I look at it. When we all got seduced to go to this cool place called the internet, we were basically sold Woodstock, right? Free love, man. Once you get there, you can be anybody, you can talk to anybody, you can do anything. It's go for it, man. No problem. Sit wherever you want, do whatever you want, wear whatever you want. It's okay. Now, because we didn't realize at the time we're building the core backbone for every business on the planet, everybody wants you to be at the opera. Show me your ticket stub. Are you in the right seat? You don't have the right dress code. You're not following proper protocol, right? I mean, it's just the drastic juxtaposition of those two environments, and that really seems like the old way is if you could get on the network, hey, and we created buckets, right? Oh, you're a technical bucket. So anything a technical person gets to, you also have an option to get to. Oh, you're a sales bucket. Well, then you know what I mean? And those rules now have changed, as you described, and we all know zero trust. I always say that means you cannot assume anything. You're not a member of any group. Every intersection, there's a stop sign. No yields, no free intersections. Everyone, there's a stop sign.
Exactly.
And you know, so, I mean, drastically, you know, I have to go back though now because I'm thinking of something you just said earlier, and it reminded me of some people think it might be a dirty word in this industry, but you were talking about certificates and certificate life cycle management. And that sounded like a horrible 3-letter acronym that we all know and hate, right? PKI. Yeah. So, you know, talk a little bit about how, because that, I mean, come on, man, that's been you know, everybody says they need it and want it, but everybody hates it because it was such an arduous process so how did you change that game?
Actually, I want to connect it to the previous statement that you said, that initially everything was open, it was like a Woodstock, everybody was welcome, and then you had to do some hardening work because, unfortunately, this is probably the human nature. People try to find exploits and try to find ways to take advantage of not that secure situation. I think certificates are probably an evolution of that as well. If you remember at the very beginning of the internet, most web applications, most web pages were HTTP, basically plain text. Everybody can just look at them and see the content, and then you realize that some sensitive information is going back and forth from your client environment to the server side and vice versa. So you had to make sure that you're speaking with the actual application that you wish to speak with. Right. And I guess this is where the standard today in the industry that you cannot develop HTTP applications. You have to do that in a secure fashion. And how can you make sure that you're actually speaking with the right entity? This is one way of applying PKI certificates on web applications. Right. Another form is to perform authentication to the server side. So client-side certification, it can be used as your identity. Like you can prove that who you say you are. I'm speaking from an application perspective. Right. And the one thing that you probably wish not to do as a bad practice is to have a long-lasting certificate. The reason for that is that anything that is sensitive and long-lasting is a bad combination. Right. If somebody gets access to this sensitive information and given them enough time, it will happen. Then somebody can take an advantage or exploit this situation by stealing the private key that is associated with this certificate and somehow impersonate or pretend to be somebody that they're not. So the concept is to do, on one side, secure fashion, like having a certificate and a private key, but on the other side, make sure that the certificate is not that long. So it has an expiration period, which is relatively short. If in the past it was maybe a few years, today the best practice is probably to do that shorter than that, maybe 3 months or something like that, maybe even shorter than that. The challenge, the trade-off is always like that between security and usability. If you want to make something very usable, you can give it like 100 years of expiration. You don't have to think about it in your lifetime. But if you do that every 3 months, then it's something that you have to think about, and you have to
Yep.
automate it, and you have to make sure that you have the supporting infrastructure. And that's not an easy task to do in a proper manner.
Yep.
And this is what we try to do. So basically, we have built all this supporting infrastructure that it will be done fully automated without any human intervention in the process. You can basically define an application, have a scheduled task based on the expiration period that will issue a new certificate and a new private key, and will provision that new certificate and the private key before the existing certificates expires, and with that assure service continuity. The user will not have to see this sign that the certificate has expired or unauthorized or whatever. And this is very useful for organizations.
So I have to tell you this, years and years ago, it was actually the first company Checkpoint acquired. I worked for a company called MetaInfo, and I actually bought it back from Checkpoint. And when I had it, we were thinking about, and I share this with you because it sounds strikingly similar, timing's everything and execution, but Authentics, I don't know if you remember that company, they made a little USB key, and there was a little memory space inside that we could put a key, a certificate into this space. So I know you've heard of a UB key. We had it. It was called the IP key. And what we did was we literally looked at certificates like DHCP. And we actually used the same acronym, Dynamic Host Certificate Protocol, instead of Dynamic Host Configuration Protocol. And we put a time to live to very, very short. And in the DHCP process, we would check the memory of the USB key to check the certificate. And if it was there, you'd then be able to proceed, get a fully authenticated address, and go on and connect.
That's
if
awesome.
It wasn't, you wouldn't. We had that working, Ori, and it was
so
really...
You combined three types of technologies that we discussed during today's chat. It's zero trust network access, because this allowed you to access the network by receiving this IP address based on multi-factor authentication or two-factor authentication, what was the physical device. And this was based on short-lived certificate, right?
Exactly. But nobody cared. And it was at a completely different time, right? We're talking 2003, 2004 was when we had it. But what kind of pushed us in that direction, and what I wanted to ask you about, is, have you heard of, there's something, it was an open source project called opportunistic encryption. And you should be able to find documents, white papers, information on it, because I don't think it's still active, but it was this whole notion of two hosts connecting on the network. When they meet each other and they're both trusted, they would immediately exchange keys at that first software layer 3, and you disappear. And it was really pretty awesome. And so that was what kind of got us going, because what we were originally thinking about was thinking first about doing this dynamic key with an IP key. But then we really hit on the fact, I think what you guys hit on, and that is, wow, this would be an amazing automated certificate infrastructure that would remove all the PKI pains if you did it right. So I find it interesting, and it sounds somewhat similar to what we had kind of played with back then.
I'm not saying it's not going to solve the problem that we discussed, but initially you have like a chicken and an egg problem, right? In order to perform this opportunistic encryption, you had to have either an initial secret shared between the two parties
Yes.
or to do something like a key exchange algorithm between the two things.
Exactly.
And in either case, you have an initial secret, whether it's a private key or a symmetric key.
Yep.
And that is the sensitive part that we're actually trying to address, because the certificate by itself is not the big issue. The certificate is public, right? If you look at the TLS certificate, you can extract it from any website that you wish.
Yep.
But what you don't want to keep in a persistent manner is this sensitive key or this initial secret that we're talking about. And this operation is something that we're solving. We're solving, basically, you can see that as a key rotation mechanism, a fully automated key rotation mechanism, which I'm sure is applicable even with your solution or your idea that you implemented once.
Well, that was a long, long time ago when I had a full head of hair, but it's still, it's fascinating, just, how the industry's evolved and how technologies evolve. Because, I had this conversation with a guy the other day, and so we know Moore's Law, right? Everybody knows Moore's Law if you're in the industry. Now, albeit the technological advances that made Moore's Law reality may not be the same technological advances that are occurring today, but it's still advancing at a very comparable rate in terms of the overall performance. And here's what I'm getting to. We've spent a fair amount of time talking about this, literally from Woodstock to the opera, this drastic change that we want to, we've all, we're in the process of making, right? I mean, we're fixing the plane, but we don't want to land it, right? So we're in flight and we're fixing it. But here's my question, and this is, hindsight's always 2010, but it's fun to discuss. Moore's Law came out when? 70s? Mid, later, 77, 76, 78, something like that. Okay. When did the internet hit us? Really?
90-something,
like
90s.
Very
popular.
95.
It was before that, but it was become a commodity in the 90s.
Right. So my point, Moore's Law, 77, 87, 97, almost 20 years before the internet really starts taking off. Certainly 10 years before ARPANET and everything came about, okay? I think you'll agree, if we would have just stopped for a second and really looked at what we were constructing and extrapolate Moore's Law in as many aspects as we could, bandwidth, connectivity, wireless, compute, right? Would we have maybe conceived of an environment that focused far less on the network, the connections, and really the data, right? That we would see, because let's face it, many of the limitations or the technologies we used years ago were because I had to dial up, or my connection was only a T1 and I don't, the limitations were because Moore's Law had not moved as far as we knew it was going to.
And I think that what helped us, I'm completely with you in this direction. I'm just saying that when Moore's Law was kind of developed, the theory, nobody thought about cloud computing, because it was obvious that there is one machine, a centralized machine in a single location with a single processor, and you always chased yourself to develop it and basically to double the performance and scale given a single machine. But at some point in time, it was more cost effective to add more machines rather than to improve the performance of a single processor, a single CPU, and still gain the same bandwidth, still get the same scale, the same network performance, etc. And this is where we're at. I think, if you talk about from timeline perspective, around the first decade of 2000, this is where cloud computing started to evolve and to become again publicly available until today. And nobody think about a specific machine, because bare metal hosts are no no longer part of the terminology. We're talking about number
that's
of
true.
processors, even if they are composed of
it's the
multiple
aggregate,
physical machines.
right?
Exactly.
Right. It's the aggregate, and it is also the fact that all the wires went away.
Mm-hmm.
I mean, you have to take that a step further. That without any wires, that means I'm not connected to any one direct thing. I'm connected to everything.
Mm-hmm.
And that's a game-changing way of looking at. So it's the aggregate of the processors that I can get to from anywhere to anywhere.
And it's this some mind shifting of how you develop software even. So the shift from developing a monolith, stateful application running in a single processor, single environment, to microservices architecture, which are ideally stateless by nature, by the type. The data is stored somewhere else. In a remote database. And by that you can achieve more efficient applications that are much easier to debug, much easier to address, to fix bugs, because they can spin up as many instances as you wish. There is no single point of failure when something goes wrong. They're smaller, so they're easier to understand. Okay, they're less complex than it used to be in a single environment. And I think that this is probably the biggest change that cloud computing has brought to software development. The way of thinking about disaggregating business logic into multiple components, smaller ones. If in the past it was like maybe functions, today they're microservices. They can communicate with one another. They can pass information, pass data. And that's how things work today.
One of the things I've pondered about, and look, I've said this a couple times. I'll say it again. I'm the Gilligan man. I'm not technical. I kind of get it, I think, sometimes. But one of the things I've pondered about is in this new world, and you're the perfect guy to ask this to, software development, saving a file, right? When are we going to look at securing the data by scattering it everywhere and only me having the ability to reassemble it? And maybe that's too far out, but I think to myself,
to a certain degree this is already happening. I mean, eventually when cloud computing was developed, one of the biggest problems that they had to address is where to store the persistent data. I'm not talking necessarily about databases. I'm talking about file system and the way to abstract it. And I think that the evolution in AWS, they call it the EBS, the Elastic Block Service. And basically abstracting file system structure from an OS perspective to work over the network to multiple physical machines. It's not just one. Okay. And this is to a certain degree what you just described. It's disaggregating the physical bits and bytes. And basically putting them in different locations by replicating it, by sharding it to different positions. But from an OS perspective, there's still files in the file system. And when you read them, you basically aggregate them together to read the content and reflect it to the application.
So for me, I guess I think of, I don't need wires. I think of the quantum compute power. Storage is like, who cares? I never think twice about saving a picture. In fact, I don't even save it. I just take it and take it and take it, and they're always there, right? So I just think and I'm not a developer, Ori, you are, but it seems like the world we're in today has just totally rewritten the rules on where files reside, where the compute occurs. It used to be I had to really think about the data set and how large I had to answer or provide to the client because the pipe was so small, right? And so, but today, man, oh man, oh man, I would think if we accept that I'm always connected, just that change in development is remarkable. And now we still, it happens once in a while. It doesn't, I'm trying to think of the app that did this. But it says, it doesn't appear you're connected to the internet. You have to wait. Oh, I think it was my Duolingo. It was my Duolingo. But here's the point. We now actually can build an application that assumes there's a high speed, persistent connection at all times.
Mm-hmm.
And that in and of itself really rewrites the rules on data stores and where things reside and where the code gets executed. I mean, it really seems like we're at a time of kind of rebirth on application development and design. Am I off?
Absolutely right. And I will have to add on top of that. If in the past, like 20 years ago, it was quite a complex problem for a single individual to build an enterprise-grade application, because you had to rely on a lot of infrastructure and build it by yourself. I'm talking about scalability, I'm talking about availability, I'm talking about the persistency and replication and whatever.
All the 5 nines.
And today, yeah, exactly. And today, a single person in few clicks can provision an enterprise-grade software
from his bedroom
just by relying, on the cloud infrastructure. And that's amazing to think about that.
It is.
It's amazing because small startup companies can, the time to market, the time from the idea that they have in mind until full implementation and provisioning and getting into production is amazingly fast. If it in the past it could take years, today we're talking weeks and months, and that's unbelievable.
Well, and what we've also seen in spades, something I think we all know, but it is the scale. If we have something the world wants to know about, right? Because, Ori, I did this research before, so I know this data. In 1995, there were 16 million people using the internet. Okay. Today, it's about 3.8 billion. And
not just humans. I'm not talking about applications that are communicating with one another. Yeah.
Correct. But what I think about is ChatGPT, 100 million users in 2 months, 3 months, right? That's what I'm talking about. So if Ori and Grant, come up with something, a new jingle, a funny meme, a new dance routine, whatever that grabs the hearts and minds of the masses, we now can get there that quickly, unlike any other time in our history. Because, think about it. If you really truly can be an overnight sensation if you just hit it right. And it's to think that you have access to platform. I'm sorry, but to think you have access, it is, and it's accessibility.
It was based on physical collaboration, right? We had to carry rocks together. We had to carry, lobs of trees and build something. Now you can collaborate from the other side of the globe by providing a software that another person or another company or organization is consuming and using it to build something bigger than what you.
It's extraordinary.
Infrastructure did. Yeah,
it's
unbelievable. And that's
and it's exciting. I think I even being a Gilligan, even not being as technical, I think as I wish I was sometimes. I just absolutely love this business. I feel so fortunate that I fell into it, and it's fun because something I've said before, and I really believe still to this day, no matter when you get into this industry, you're getting in at the beginning of something. And
Yeah, I agree with you.
that's exciting.
And that's what I like about what I do, about the fact that every a few months, every few years, the technologies are evolving around you. If you don't learn the new technologies, you basically stay behind. When I
It's
started
true.
in the industry, nobody spoke about the containers and the container orchestration platforms and cloud services, and this evolution was something that I grew into it. I mean, I
Right.
adjusted myself, my skill set, my knowledge for all those new technologies, and I'm sure that in a few years' time, we will talk about different types of technology. If it's
No
based on
doubt.
AI or on different kinds of environments.
Yep.
That's the human or modern evolution of technology nowadays.
Yeah. You know, it's something you touched on it. You brought it up. I got to pull on it a little bit since it is the topic du jour. And it's a fun thing. I talk a lot about it. And that's, AI, artificial intelligence. And again, I mean, I'm no expert, but I've really tried to immerse myself and understand LLMs and transformer and some of the major technological advances that have occurred recently that has caused this. Because what I found, Ori, is most of those 100 million are lemmings. Most of those 100 million don't have a clue to the fact, don't know about transformer, don't know about that technological advancement, don't know about the fact that it's actually a prediction of the next word or letter. I mean, some of the things and for me, I want to be as informed as possible, but, AI is going to be a game changer, but I don't see it yet taking jobs per se. Yeah, they've got some robots that are going to take boxes and move them around a warehouse. And I think most humans would say, God, that's great. But I don't see AI like, for example, you can use Claude or ChatGPT or any of them and write a marketing plan, and they're brilliant. They're brilliant, but they don't execute it. Someone else still has to execute it.
I'll agree with you. If the assumption is that they're going to entirely replace humans, I don't think this is the direction. But I look at it as software evolution happened like 20 or 30 years ago. Software helped to humans to become more efficient in what they do, right? Computers help them to be more precise about calculation, more specific about some of the jobs, to automate process. So less human, with the help of computers, could do things more efficiently. I think AI is another step in that direction. So it's going to help us do things more efficient. Like if I have to write a document today, I can consult with, ChatGPT, for example, to give me the basis, but I still have to do the adjustments and I still have to do the tweaks here and there. But it's going to save me some time that I can now utilize it to do something else. So I'm becoming more efficient version of myself. And I think this is the direction that we're going to see. And it's going to, like the same way that I mentioned about cloud computing, helping individuals becoming more like a superhuman, like becoming, we have the ability to release enterprise-grade software with a few people, like a small startup company in the garage. Now I'm able to write maybe more sophisticated ideas with the help of AI. Where, for example, Copilot is like an engine that helps me develop software, like becoming basically doubling up my ability to develop software in much faster scale without hiring more people. So again, efficiency is the key word here.
So I had the wonderful pleasure of getting to know, and I call him a friend now, the global CISO for HPE, Bobby Ford. And I think he was spot on when he said, and he was talking specifically in the context of security professionals. He said, I don't believe AI is going to put security professionals out of work. It's not going to take their jobs. But the security professional not using AI is going to lose his or her job to a security professional who is using AI. And I've kind of adopted that even at a higher level. I think you can apply that universally across every individual. You're not going to get replaced by AI. You're going to get replaced by the guy or girl that uses AI and eats your lunch at the same job. And so that's why I do believe the most, I mean, and I'd love to hear what you think. I always tell people, think of Gen AI, think of ChatGPT, Claude as an assistant. You've got an assistant that knows everything the internet knows, but is dumb as a rock without the right prompt. And the world has moved to learning how and knowing how to prompt these data stores, if you will, right? I mean, that's going to be the name of the game. And I think this whole RAG approach is very interesting to enable organizations to build, use the LLM, but have it grounded in facts that are more current, right? But I think it's fascinating.
Yeah, it makes perfect sense, and you can see this example in previous technologies that were evolving in the last decades. If you don't adjust yourself to new technologies, if you don't observe them, if you don't use them, if you don't react to them, you will find yourself simply behind, and that's just a matter of time until you become less relevant. And I don't see people today that are objecting or rejecting cloud computing, because it's de facto what runs software today everywhere. And the same thing will happen with AI. I mean, it just now we're starting to see the seeds. Basically, the seeds were planted a few decades ago. I was a student in the university 20 years ago, and we learned about AI, but now it's becoming more usable technology, something that is actual reality. Engines like that help you to do things today that in the past you had to invest a lot of time and energy to teach models, to teach to learn the AI engines to act as you wish. Today you have predefined models. You can use something that was already taught. You can make value. You can make you can present the value of that using your application in a matter of minutes.
Yep. You know, you talk about the cloud. One of the things I a lot of times will ask my audience is I'll put up a slide of a big paddle wheel in a river, right? And I'll say, how many of you have one of these behind your house powering everything you own? And of course, no one does, right? What do? You plug in and then you pay the bill once a month to the electric company, right? And this is why I absolutely unequivocally believe the cloud model, the as a service model, SaaS, this is the compute model that's going to prevail for decades. It will only evolve and get faster, better. That's not to say that there aren't instances where I'll have a private network that's on premise that I own and maintain. But by and large, the world will be as a service, no different than my water, no different than my electric. I mean, it's going to be my cable, everything. It just makes sense. So
I love this analogy because I think it applies to not just to technology. Like if you had like hundreds of years ago, people were trading chickens to tomatoes to cucumbers or whatever. It was because somebody was an expert in growing and selling and providing the best tomatoes in the world. This was the first probably as a service component that you had. And now today I'm an expert in building software to manage secrets. There is no point for you to develop your own tool because there is somebody else who is is very excellent in what they do. And instead of that, you can just consume services from other vendors that in things that you're less expert in, like managing my tickets. I purchase software for managing tickets, and if I want to send emails,
So there's a guy, I have to just tell this quick story. In 1988, I had the wonderful benefit. I was working for Apple at the time. Arco BP was my customers. We had a level 3 corporate briefing, and level 3 at Apple meant 18 plus months in the future. It was very, very difficult to get. There was a man named Chris Espinoza, and anybody in the development industry from years ago knows he wrote Apple ProDOS. I mean, he was the one that created the OS. And he was in talking, and this was, several years, 3-4 years after the Mac had been introduced, but he was in talking about the future of software development. And and it was fascinating. And again, remember, 1988. And this was at a time when Microsoft Word was this monolithic. They were adding glossaries, and I mean, all right. The trend was to make these huge monolithic, it does everything app, right? And Chris Espinoza stood up and proposed that the future of application development was what he referred to at the time as applets. Now we call them apps. He was so spot on, but what he described was, today you've got a word processor that has getting thesaurus and spell checker and all these things. In the future, all of those components will be stratified, and you'll be able to pick the very best thesaurus and the very best text editor and the very best dictionary, and have them all work together. And that's exactly what you're describing. And in fact, it's exactly what we see today with the evolution of iOS and the applets, right? But this was 1988. And I thought, man,
amazing.
Really remarkable.
That's seeing the future before it happens. Yeah.
Totally, but spot on. And I believe, taking it a step further with the conversation we've been having about cloud, it's Legos, man. It's Legos. And you can build the Starship Enterprise or a little teeny car, but you have access to it, right? It's really, really, it's exciting.
What I like about it, that you can take this analogy and apply it to any type of implementation in the history. Electrical engineers were speaking the same language that you're speaking when the transistor was invented. It's like Lego. You take a transistor, they take a CPU, you add an LCD display to it, you have yourself a computer. And now that's a building block. And that's a new building block. And now you make something higher than that. I think the same will apply to AI and new technologies we see today. Those will become the new building blocks, and we simply step up to the next level and start building something new out of it. Something that we probably cannot imagine today. Maybe the visionary people will.
Yeah. Maybe I need to ask Chris Espinoza. I need to send him a note, say, hey, what do I expect? Yeah. Pretty exciting stuff. Hey, Ori, thank you. Amazing. Man, I've taken up a bunch of your time, but this is fun. I really enjoy talking with people that are so much smarter than me, and just, being in the biz for a long time is just fun.
And I think part of the conversation is to inspire one another to think about new analogies and things to speak about. And I'm happy to join any future conversations once the opportunity arises. And thank you for hosting me here, Grant.
Terrific.
Really my pleasure.
Yeah, a lot of fun, Ori. Thank you very much. Ladies and gentlemen, I hope you enjoyed this conversation as much. I mean, it's probably impossible that you enjoyed it as much as I did, but maybe close, because I'm the one that got to have it. But Senior Vice President of Akeyless Security, Ori Mankali, fabulous conversation. Thanks a ton, man. I look forward to having you back. And ladies and gentlemen, if you liked what you heard, please share it, like it, tell your friends about it, and come on back. We'll look forward to having you back on the next episode of Talking Cloud. Thanks so very much.
Thank you very much.